Good morning, everyone. My name is Patrick Swartz. I work for SUSE this year. Last year, this time, I was up here speaking to you as a customer. So I've been on your side of the table. With me today also, I have Rain Curtis, who's with our professional services consulting team. So I'm on our sales engineering team, so what I sell, he fixes. So, but thank you for coming. Obviously, this is a topic that must be near and dear to everyone's heart on bare metal recovery. We have a full room. Thank you for attending, and I hope not to disappoint. So today, as we get started, first of all, our introductions, who we are, what we're doing here, what we're going to do. What's the use case? What are we trying to solve? As we heard some great keynotes today, you know, I love that Mike Place's idea of simplicity is complex. And I won't even come close to Mike's talk. I thought it was a brilliant talk, but we will kind of break down a little bit of using a very simple idea in SALT to solve a somewhat seemingly complex problem. And I hope that some of the ideas that we present today, you'll be able to take back with you and find a way to implement in your environment. We're going to talk a little bit about REAR and what that is and how we do it manually and why do we need to do it. And then how do we go about automating what we've discovered? And then we'll review a little bit, and then we'll open up to some questions and answers. Sound good? All right. So our use case, what are we trying to solve here? And this time last year, as I said, I belonged to another company, and it was fairly large. We had a lot of need to find a way to recover systems regardless of what state they were in and what happened to them, you know. And so we were trying to solve here, well, one of our needs was bare metal recovery. More than just backing up from a recent backup. We needed more than that. We needed a way to bring the system exactly the way it was before something tragic happened. But also, not just that, we needed to find a way to automate this so that we can guarantee that at any time, any point in time, what we had available to us was the most current, most available system that we could provide back to where it was prior to the tragic event. So what were some of our requirements? Well, first of all, we needed to be able to duplicate the system like it was prior to that incident. We needed to possibly restore on dissimilar hardware, going from a VM to a physical, going from physical to a VM. What do we have? Going from KVM to Zen. You know, what do we need? We need to be able to get back, bring that system back up, regardless of what system we had before. We also needed to, you know, in doing that, we needed to make sure it was the most current available image possible for that system. So in doing that, the team that I worked with did some research, looked out there at what was available to us. You know, being a publicly traded company, we had to be very judicial in how much we spent and what we didn't spend. So the solution that was determined was this product called, this open source solution called Relax and Recover. It's a bare metal recovery system solution. And you know, there's the website, there's a fun little icon, the guy relaxing in his hammock under some palm trees with his server beneath him, you know, just churning away. And that's kind of like where I'd like to be, except not on the East Coast today. That wouldn't quite work well. So here are some of the details on what Relax and Recover is. You know, this is an open source solution. It's meant to be, this is from their website, this is meant to be a set up and forget Linux bare metal disaster recovery solution. This is what the designers of it, that was one of their intents for it. Doing what it does, it creates a small bootable ISO with all the existing drivers that you need to bring that system back. It integrates with a lot of the backup solutions, both commercial and open source, like Bacula and BearOS, and some of the other commercial ones like TSM. It also integrates with a lot of different monitoring solutions so that you can keep track of where your systems are at. So there's a lot of tools within REAR. It's also designed to be well suited as a migration tool. Again, as I talked about, moving from a physical box into a virtual machine, moving from this old Pentium-based hardware to the new, something newer.
There is something newer?
There's a lot something newer is done. Yeah, sorry. How do you get Relax and Recover? Well, SUSE does provide it in our high availability extension. We also provide it within our SLES for SAP products. You can also get it from Rear keeps their official releases for all distros on OpenSUSE build service. So it's another function that SUSE provides that I'm very proud to support, the OpenSUSE build service. So it's a place to build applications regardless of what distro you're using. So Relax and Recover has chosen to use the OpenSUSE build service to host all of their distro-based builds. Well, so now that we've chosen to use Rear to do our bare metal recovery, well, first of all, you're going to let's make sure it works first, okay? Well, how do we do this? How do we use Rear? Well, first you've got to install it. You got to go get the distro wherever you get it from, whether it's from SUSE HA or from the OpenSUSE build service solution. You got to make sure there's a config file. You got to make sure you deploy the config file. And I'm talking, yes, there's a lot of ways you can do this in Salt, but initially you got to get that config file out there. Then the command that they use within Rear is called make rescue or mk rescue. So you got to run this rescue command, and it creates some files, and some of them are temp files that you've then got to go back and clean up because it doesn't do that on its own. Well, not only that, then you have to validate that install and that config and that execute worked, and then it worked across every client. You've got to, again, it's not like the one commercial where you see it says, I don't test my code unless I do it in production. Well, maybe we can do it before this event happens. So here's an example of the local config on my little lab here on my laptop. Talking about, you can see I've chosen my backup method as my netfs. I'm telling it to the output to an ISO file. And I give it my backup server and some backup options to make sure that I can write to my backup, my NFS share. So that's, that was what's very simple. And there's a lot of other options you can look at in the Rear manual on the options you can put in here. It's very detailed. Well, here's an example of when I ran Rear Makeup on my laptop. And you can talk about it. It shows where it ran. Let's see if my pointer works here. Turn it on first. You can see where here, it's going to run. It's going to copy all my binary files, my kernel level files, my modules, and everything here. And then at the very end, it's going to write this ISO image to a temp directory and then copy it to my NFS share that I have put in my local config. So that's Rear in a nutshell. That's what we've done to make sure that this works. And we'll show you an example of what it looks like when you go to mount that at toward the end of our presentation.
So Patrick, I have to do this on every system?
Every system. And then every time it changes, you got to do it again. So it's a static view of your system as it looks right this moment. Something changes to your system, you've got to go back to it, rerun this make rescue to get a new copy of that ISO. Your disk change, a network change, there's a lot of things that Rear watches for to see if something's changed on the system. Well, then you've got to go back to your systems, rerun Rear to create that new ISO, and talk to your backup system and get a new backup view of that box. So that's cumbersome. I mean, it works on 5 or 10 servers. When you got to do 5 or 10,000 servers, so that gets a little bit more involved. So let's automate this, all right? We're at a SALT conference. We're all about automation. So let's automate this process. Well, one of the key features I want to talk about today is kind of buried in the SALT documentation. And this is a cut and paste right out of SALT docs about beacons. And what we're going to do, one of the key things that we're going to do for this automation is actually use pillars to deploy a beacon, okay? And that's at the very end of this configuration on beacons, it talks about, and I highlighted it in yellow there, you can add it to pillars for that minion. And I think that's a very important function within Salt that kind of gets overlooked a lot of times, is the ability to use pillar data to deploy beacons. And so that's the basis of the rest of the solution we're going to talk about today. All right? So in doing that, I've got a really quick little example here. So putting it all together, you've got your standard Salt master, you've got your reactor, your pillar, your state files, your event bus. It's listening, it's waiting, okay? A new Salt minion comes online. And it happens, we've got some code already set up, we'll show you in a second, that's listening for a particular match in our grain. Well, as soon as that match is made, the master is going to apply the beacon to the minion. All right? First step, right off the bat. That brand new minion comes on, it matches that particular grain. Maybe we're matching for minion ID. And it matches that perfectly. It's going to deploy that beacon to that minion. And then once that happens, the fun stuff really starts to take place. The event tag is recognized by the Reactor, which then happens to map to a state file we've already prepared, which then kicks off the rear state, which installs rear and kicks off a make rescue. Okay? So with me so far? And once that kicks off, the resulting ISO is written to the remote storage, in this case, my NFS server, and a backup is ran to my backup server. All right? That's, in a nutshell, what we've done in this process. And then if something changes on my box, the beacon in Reactor automatically then repeats this cycle. If my kernel changes, then the system will then recognize that change and kick off the whole process again. And since we're Salt, we don't have to worry about reinstalling rear because it's already there. Our system checks to make sure it's there. If there's a newer version that happens to be on a repo, we'll deploy the new version at the same time. It will recreate a whole new ISO and make sure that our backup is the most current. So that now I have taken me having to go out to all these systems and making sure, hey, didn't we update that whole group of servers in the DMZ last week? Did we go back and create a new make rescue image of it? Oh man, we forgot. We got too busy. Well, this system manages it for us. Now we truly have done what rear has intended to do of set it and forget it, because we have everything in place to process and create our system. Everybody with me so far? All right, so let's look at some of the files that we had to put in place to make this happen. All right, well, first we needed a pillar top file, and very simply, in my example here, we're looking at to match the minion ID in my example as the client. It's the beginning of, I've got SC client star because I'm looking for anything that starts with SC client. If my minion matches that and my minion ID, boom, it's going to get this beacons rear file, which happens to look something like this. So here's my beacon that I've stored in my pillar data. And again, this is the crux of what we're doing here. In pillars, we're now deploying our beacon. And our beacon, first we're going to use rear. And we're going to look at in this case, I just turned it down to every 3,000 seconds. You're not going to do that in production. That'd be kind of silly, but once a day is nice. And we're going to, of course, disable during state run so that while it's being changed, Salt's not going to try to kick it off again. We're also using another function along with rear called iNotify, and we're going to watch the boot directory. And we're going to use the mask of modify, recurse true, and auto add true. So like when we do a new kernel update, it's obviously going to add new files to /boot. And so if rear didn't grab it, then iNotify will.
Can I add something to that? So if you're not familiar with the iNotify beacon, it is part of just the standard modules for Salt. And so just by implementing this beacon configuration and giving it to those minions through the pillar top file, all of those systems will now have the iNotify. And as Patrick mentioned, right, as we update our kernels, we need a new rescue disk, right? We might have new drivers, new version of drivers. And so that's why we're watching that /boot directory. The other thing I wanted to mention on here is this rear beacon that we've created. This beacon also needs to be pushed out to the different systems. And this beacon is not part of the standard SALT library or distribution. So this is something we've written. So we have to push this out to our minions. There's a rear.py that's going to read this configuration on our 1,000 minions that we need to back up. So we can distribute that through, if you're not familiar, by using dynamic module loading. So in serve salt, we can create an _beacons directory. We put our rear.py in there, and then we can do a sync all or sync beacons, and then that will push that module down to the minion, okay? We may want to do that through a state because since it is a beacon module, we'll need to restart the minion for that to take effect. When it restarts, it will look for its beacon configuration, which we've just given it when it reads the pillar data. Any questions about how that's put together? Okay. Oh, yeah.
As far as restarting the minion, would that be a manual operation?
Yeah, well, it's a good question. So it could be as simple as you do this through a state, you could do like a command run in the state, and then typically, if you look at like the SALT documentation, it says to run salt call service.restart salt-minion. And so I would do a sync all, then I would restart the minion, and then I'd be in business. Yeah. I'm sorry, what's the best way to do what?
If we don't have an option to restart the minion service, but still we want to push this configuration or minion, is there any way to do it only with the S4 pillars?
So,
Repeat the question.
if I understand your question, you're asking, is there a way to implement this beacon without having to restart the minion? So it's got to be there. And so if you don't use like the dynamic module loading, then you will have to push it down and do it initially. So sometimes people do it as part of their provisioning. When they have custom modules, they'll lay them down as part of that provision, so when the minion comes out the first time, it's already there. And then also, I would recommend the dynamic module loading, just because okay, so I've got version 1 of my rear.py for this beacon. Well, when version 2 comes out, just by running saltutil sync all is the easiest way to get that out to all my systems for the new code. So, thanks. So the beacon configuration can be in the minion configuration. It's just that we want to manage it centrally through pillar in this solution.
Good questions. Thank you. So let's continue looking at some of the other master files we've had to put in place prior to our first minion coming online. Well, we talked about the reactor, and this is our reactor conf. And in this, we can see what we're trying to watch for. And we're looking for the beacon. We're looking for a rear out of date, a rear not installed, and of course the iNotify boot directory changes with iNotify. And all of these, you see, they're going to kick off the reactor rear state.
Also, sorry if I can.
No, jump in.
The other thing I was just going to say on this is when you look at these different events that we're looking at, these map specifically to that rear.py beacon. So if you look at the documentation of what does it take to write a beacon, you have to have a beacon function that's going to accept a config. Okay, that's pretty easy. We can do that. But then it has to return a dictionary. Okay, that dictionary is a list of events that you want to be published, right? Because that's what a beacon does, firing off events. And so these are the list of events that our beacon will be publishing. So we want to react to these events, and that's the role they play in this configuration.
And then, of course, we follow it up with our actual rear state file of what we're trying to push here from our reactor. This is what our reactor config. Simple, a couple of lines of code here. And this is an example, and I didn't cut all of the code in here because I don't have permission to publish it all. I didn't write this. This is the custom beacon, the rear custom beacon. I'm hoping that the gentleman that wrote this actual beacon gives us permission and we can publish it. When this YouTube video comes out, if we get permission at that point, I'll post it at the bottom of the YouTube video. But I was able to post chunks of the important part of the code. And you can see how, for the most part, it's fairly simple to write your own custom beacons. And what he had done here, he talked about, reaction recover, determines, in his case, TFSIM is installed. It also checks to make sure rear ISO is valid or not. And if not, fires off the event and reacts to the rear state on the minion. He talked about the definition of the beacon config there. And then here, on the next screen over here, these are the events we'll want to return. Again, you can see my rear not installed, my rear out of date, rear all good, even rear TSM is missing. Which then, we had another beacon that talked about installing TSM. Because it returned, this beacon then also returned that. And we can then see the rest of our piece here of the custom beacon that he wrote. Sound good? And of course, we have to end it all with a state file and actually doing what we needed to do. And again, I didn't cut and paste all of the state file here. I just kind of put in the highlights of what we're trying to cover. The create the rescue ISO piece. We can see we're doing a command.run to do the rear make rescue. And at the very end, we're doing a rear succeed email message and then tells us so that we can have that email every time something changed in the system. We can get an email automated to our inbox to know that, yes, we had a good rear backup recently made because we deployed a new kernel, or the network config changed, or somebody overnight had to increase the size of a disk volume. All those are events that would have caused rear or iNotify to kick off a new instance of our process. Okay, then of course we get to the very end where we want to make sure that this really works. Of course, that whole I don't test my code unless it's in production mentality. But here we go. We're going to start off from our interface server. We grab our ISO that we've created, and this is an example of using. And in this case, I'm using KVM to mount that ISO and to kick off an install. This is the rear menu that you're presented, and you can see at the bottom I've got my NFS share. It knows where to go. Had this been to another open source or commercial backup system, that data would have been in here as well, and how to connect to that, because all the drivers for my backup would have been in here. All the access permissions for that backup system would have been built into this ISO. So it already knows how to connect to my backup system, pull down the latest backup that I had of my box, and when it's all said and done, it hits the backup server, and boom, I have a new system. Question?
Is it possible to point it somewhere else? Like my backup server failed and I need to point it elsewhere?
I think there's a secondary, yeah.
And another one was earlier in the talk, there's SaltStack was mentioned. This seems manual, right?
That's a good point. Yeah, I'm sure there's a lot of ways to take this piece of automation and even automate it even further.
Yeah, and I would say that with Salt Boot, we're doing like our initial provisioning. This is more of our recovery provisioning. And what Patrick's showing here is that we've got an ISO that we're booting off of. There are some manual steps, but that's why we're using Salt to automate this. Within Rear, you're able to actually say, rather than build an ISO, build a Pixie config for me. And then you could just boot off the network and do your deployments that way. So, yep.
Yeah, so conceptually, there's no reason why we couldn't combine the two. But at the moment, Rear already handles the stuff that we are doing with Salt in our Salt boot, because it will already have an ISO image that comes up with the right network connections and everything. It's of course, a different approach because you need to clone a system first. The Salt boot approach is more like you proactively, describe how your network should look like, how your partition should look like, and you can repeat it by running the Salt boot workflow from a RAM disk. So some of what Rear can do, you could probably also do with a Salt boot. Yeah.
Thank you.
Any other questions so far? Yes, sir.
So with the you build versus restore, if you're doing like a clone recover type of process, like you're just describing, is it a lot faster to do your recovery or build a new one with like automation and have like state to define your system?
Well, it kind of depends on what was my system like before that I'm trying to recover from. If there was a lot of custom data already on that box that my automated build wouldn't have, then this would be the method I'd want to use. If it was just another web server that has static data on 1,000 of them, then maybe the automated build would be the better route to take. But if it's a unique system that has custom files within it that I had to back up every night, then then I would probably go here. It goes back to what is my need?
I would also add to that I would still do everything in states if it was me, just because of the power of Salt and the dynamic, and anytime I change it. The image approach is just, for this disaster, is just how quick do I need to get that system back up? If I can re-image it and then high state it for any deltas that might have changed since I took that back up, I would do that. But by putting the high state and all your config as much as you can, I think that would be the best approach on there. But it like I said, it depends on your requirements and also complexity that you want to take it.
So I know this has been a really quick talk so far. I tend to talk really fast. And this was a simple idea talking about what we're doing here, but I wanted to really emphasize the idea of being able to use beacons to deploy this infrastructure. So here, just quick wrap up. By combining the automation and real-time capabilities of Salt plus simple disaster recovery of Rear, we now have a fully automated process to make sure we have a current recoverable solution to our environment. And this is this is what's happening right now with the customer that we have a shared customer between SUSE and Salt, and it's working really well for them. Thankfully, they haven't had to actually put it in use a lot, but it has, especially for let's take this existing system, migrate it to a duplicate system, absolutely duplicate, but under a new host name and IP address. And this solution was able to do that for them. So by combining Rear plus SaltStack, we have woohoo, celebration time. Or as Don would say, woohoo! So we have a couple minutes yet left, and I thank you for coming, but is there more questions, ideas, or general chit-chat?
One thing I'd also add to the wrap-up is even if you decide that Rear isn't the direction you want to go, hopefully you see some of the administrative concepts that we're implementing with Salt. You can look at a lot of the Salt documentation about beacons, whichever beacon you're using, but how are you going to configure all of those hundreds or thousands of systems with that beacon? Using the strategy of putting that beacon configuration in pillar is a key concept that's going to allow you to dynamically change that as needed. Using the dynamic module loading whether it's a beacon module or any other type of module that you need to distribute to minions. So using this as a reference model, hopefully, and these concepts will make things easier as you implement beacons. And then, as I mentioned on the beacon, you're going to be able to control what events you want that minion to send back up to the master. So, yeah.
I see that you talked about making recovery ISOs. Can you move that through Pixie?
Yeah, when you do the make rescue, within your configuration, I don't know if there's a command line, I can't, but I know it's in the configuration. You can say, rather than build me an ISO, build me a Pixie configuration and put that on your Pixie server.
The rear documentation is vast. It's not very pretty, but it works well, and you can get all the information from the rear docs. This was just, in this case, I wanted to use rear as our solution for the bare metal recovery piece, but the emphasis being on the power of Pillar and the ability to, and the simplicity of actually creating your own custom modules on your beacon modules. But combining the two, you can pretty much do anything. In this case, we used rear, but like Rain said, you take this model and format and do just about anything with it.
Any other questions? All right, well, thank you for coming. We appreciate you listening. And
we'll give you back a couple more minutes of your day, and thanks.
Yeah, thanks.